Hey guys, these are going to be your concave mirror notes. These are basically the fundamentals of concave mirrors. You looked into all of them in the investigation. Now you're just going to write everything I write in your notebook here. Anything I say that you find helpful, write that down as well. Alright? Alright, so right here I have a laser box. Alright, what it is a little demo we're going to do. Out of these 5 slots, you can see comes 5 rays of light. And I'm just going to demo it on the video for you to show if we aim it at those 5 rays of light at a mirror, what happens to those rays of light. You should have an idea that if we aim them kind of like this, like horizontally coming into the mirror, how should they, how should they reflect off of the mirror? So here they come in, horizontally going in, boom, and they reflect how? All through the same, let's get a good position, all through the same point. You can see the horizontal rays coming in, and they all reflect on the investigation. You drew this through that point, and then what is that point called? It's called, well, it's labeled F, and it's called the, write this down, the focal point. Alright, so the focal point, just write down the definition here. The focal point is the point all horizontal rays reflect through. A curved or concave, curved in mirror like this, basically, it acts like a satellite, where that if a ray comes in straight or horizontally, then that ray will always reflect through the same spot. And if you had a satellite, that would be where there would be a receiver located at the focal point. So it gets all of the horizontal rays coming in, all go to the receiver right there. And it's the way it works with curved mirrors too. I mentioned that this, write this down, this mirror is called a concave, turn this off, concave mirror. Write down this definition as well. A concave mirror just means curved in. If we turned it around like that and aimed the light at it, that would be a convex mirror. We're not going to do convex mirrors right now. We're just going to do curved in mirrors, which are concave mirrors. All right. So you also defined this line right here. We're going to write that down, the definition of that line next. So start a diagram that looks like I have right here. You'll draw 2 diagrams like this. And we labeled the focal point, and we labeled the principal axis. The principal axis is right in the middle of the mirror. It's the horizontal line that comes straight out of the center of the mirror, right? So draw yourself 2 mirror diagrams like this. And what we're going to draw on these diagrams is the reflection rules for a concave mirror. Okay? You're going to need a ruler for this part to make sure you have perfectly horizontal lines and perfectly straight lines even. Our first reflection rule is that if I have light that comes horizontally in, whether it's on the top, whether it's on the bottom, it doesn't matter. If it comes in horizontally, it reflects through what? You looked into it in the investigation. It reflects through the focal point. Horizontal rays reflect through the focal point. So write that down as your first rule of reflection for concave mirrors. Horizontal rays reflect through the focal point. Great. So our next rule for concave mirrors is basically the opposite of the first rule. The question is, what if I aimed light through the focal point? I'm going to draw two different rays, one coming from the top, one coming from the bottom. Both go through the focal point. And if they go through the focal point, how do they reflect? Well, it's the opposite of our first rule. Our second rule is basically, if you switch that sentence around, rays through the focal point reflect just like this. Let's draw that a little better. There we go. Rays through the focal point reflect horizontally. So, first rule, horizontal rays reflect through the focal point, and then the opposite of that is rays that go through the focal point reflect horizontally. They're just opposites of each other, each rule. Great. Last page here. Describing concave images. Alright, so this is related to the demo with the flag and seeing the flag upside down, and related to looking at the mirror and seeing when is a concave mirror used, like a makeup mirror or a shaving mirror and things like that. Those two demos. Alright, so if you stand your body inside the focal point, you could draw that right now. If you stand right there inside the focal point, how do you see your image? And you looked into this in the lab. Well, you see your image located behind the mirror if you stand inside the focal point, right? So it says object inside the focal point. Where do you see your image all the time for that? Behind the mirror, and a little bit larger or magnified. Make yourself a dotted image person right here behind the mirror. So when you stand inside the focal point, you see a, what is it, a real or a virtual image? Well, the real side of the mirror is the side the object is on. So this would be the virtual side of the mirror that the image is on there. If it's behind the mirror, it is a virtual image. And we saw this in a shaving mirror. You could see your face the image of your face located behind the surface of the mirror and enlarged. Same thing with a makeup mirror. Your face is located beyond the surface of the mirror and is enlarged. All right. Is it inverted or upright? Is the next question we will always ask when you stand inside the focal point. It looks like when you look in it, you're still going to be, if your face is straight up, and in real life it's going to be straight up in the image. So we're going to call that upright. Inverted would be like an upside down image. Is your image magnified or is it reduced in size? Is it larger or smaller? And we know the whole point of a shaving mirror, when you stick your face inside the focal point there, is just to see a larger image of yourself. So it's magnified. You can write example, shaving or makeup mirror. And these are the three words you would describe that image. It's larger, magnified, it is upright, it's not upside down, and virtual. It seems to be located beyond the surface of the mirror, not in front of the surface of the mirror. Alright, but if you stand outside the focal point, your image looks much different in a concave mirror. If you stand outside the focal point, we just saw this when we looked at the flag demo. What does your image look like? Well, your image, we're going to still draw your image dotted here. your image looks upside down when you stand outside the focal point. So we could say inverted or upright. Well, in this case, it's inverted. Also, because we were able to catch the image of that flag on an actual screen, we know that the image exists in reality. It exists on the real side of the mirror there. If you stood outside the focal point here and we turned all the lights off and shine light on you, we'd be able to put a card right here and catch your image right there. That means it's a real image. It doesn't exist. Your eye doesn't create it on the virtual side. Your eye can actually see it on the real side of the mirror. So it's a real image. So we're going to draw your image on the real side, inverted, so upside down, when you stand outside the focal point. And is it magnified or reduced? Well, it could be kind of either or. So we're going to write depends. Sometimes it's larger, depending on how far back you stand beyond the focal point. Sometimes if you stand right up close to the focal point, it could be really big. But that's not an important question really for objects beyond the focal point. It is an important question when you talk about a shaving mirror inside the focal point there. And you get a magnified, definitely a larger image, right? Alright guys, so that is objects inside the focal point versus objects beyond the focal point, and the different types of image you see, we're going to use these verbs here. So create that table, make sure you have these images drawn. For inside the focal point, it's a virtual magnified image behind the mirror that it doesn't exist in real life. Your eye creates it. Here, if you stand outside the focal point, you could catch that image on a screen in real life, but it's upside down. And get your examples right there so you can tell the difference between these two situations.